Wait, you give me a lift to McDonald's?
Why?
I'd drive my car into a bridge.
I don't care.
It's very rude, Wayne.
To make up for it, do you want a fun fact about me?
Oh, fun fact about you, alright, go.
I'm all about that bass.
What about that bass?
No treble.
I knew you were trouble when you walked in.
Moving swiftly on.
Ah.
I need a new tailor.
Yeah.
So, Neutainer method.
Integration.
Differentiation backwards.
Absolutely. So we're going to go a brief summary of integration. We didn't do it with differentiation, but integration is evil.
From the word go.
Absolutely.
So,
if you have an example like integrating...
oh,
he's getting it himself at the moment. Say x squared plus x cubed. Cool.
Yeah, good.
So what you do is you raise the power by 1, then you divide by the new power, so you get a third of x cubed plus a quarter of x to the 4. Now say if it says to integrate between 2 points, say 2 and 0?
2 and 0 ones.
Absolutely. So you put 2 in place of x, one of them, and then you you put 0 in place of the other one.
I'm not actually going to do the maths because it's core 1, but
Yeah,
you know what we mean.
And then you get the area under a curve. Thumbs up, that's very handy, summary over. But it gets a bit worse, doesn't it, Wayne?
It definitely doesn't get better. Say goodbye to sleeping.
Yeah, and everything.
Yep. Knowing anything about anything but integration, say goodbye if you want to understand integration.
Goodbye.
Goodbye.
On that bombshell, no we don't. So, integration.
Yes, so first we'll start off with a few things you just have to know.
Like in differentiation, it starts with a few things. So, e to the x?
E to the x.
Alright.
So if you're differentiating,
Integrating
e to the x.
Then, a way to think about it is differentiating, what to differentiate to get to the e to the x, and then go backwards.
Yeah.
So when you differentiate e to the x, you get e to the x. So if you integrate e to the x, you'd get e to the x.
Good, we got that.
Nailed
We got it.
Done it.
So a harder example.
I think sine. Who should do it? Sine. Yeah.
I'm going to make it even worse. I'm going to
Even
say
worse?
sine 2x.
You're an evil man, Wayne. An evil man.
Can't help it. Can't help
Okay,
it. I'm
so-
going to do the answer in red because it's evil.
It is evil. So okay. What do you differentiate to get sine?
Well, cos, but that would
Yeah.
give you minus sine.
It would. So what have you differentiated minus cos?
Minus. That works.
It does.
Right,
So
yeah.
okay.
Minus cos.
Cos 2x. Yeah.
Do you see a problem with this?
Oh, I sure do, Wayne.
Yeah.
There's a gap between the minus and the cos.
There is. That's sort of related to what I was getting at.
Yeah.
Let's just say for a second this was right. If you differentiate that, you're going to get the plus sign, but you're going to get 2 sine 2x.
That's not what I want, Wayne.
So what could we put here to not have 2 as the coefficient of the product is a half.
It is a half.
So how evil is that? Minus
that's-
and a half.
So that's that. So if we then do cos,
Yep. So I'll do the... I'm going to do cos 3x.
Okay.
X, just to make a point. It's going to be a third sine x, because if you differentiate that,
sine, yeah, you get cos.
these could all do with having a plus c on the end.
They could, but you don't know what the cos plus c is yet at the moment. You put it... No, you didn't, yeah, no, never mind.
And often they condone not having one, but...
And that's all fine and well good, but we missed one out, Wayne.
We did, I was saving it, because it's so evil, red can't even handle it.
No, we're going to have to use purple.
Absolutely.
Now, purple isn't very evil, but it is though, so that's okay.
There's none made in Bic, and that's pretty evil.
That's pretty evil, and Eddings begins with an E, and so does evil, so that's...
There you go, there you go.
There's the link. Here's a pen.
Thank you. So it's 1 over x we're doing.
It is 1 over x. You remember when you differentiate ln x in the last chapter, or just in life, you get 1 over x. So you'd think that if you integrated 1 over x, you'd get ln x.
Yeah.
Do you?
Well, no.
No.
Not quite, but very close.
You sometimes do, depending on what x is.
And the reason is, if we just draw over here.
Alright, I draw a little graph of what ln x is. You'll see that it doesn't exist in a certain place. In a certain place is the negative part of the x-axis.
Yeah, because it gets closer and closer to this.
Never touched it.
Because it's a reflection in the y equals x axis thingy.
Yeah, it's
Of
the inverse of e to the x. So,
If this is negative, it doesn't exist. But
So-
how can we get rid of that?
well, a few rules, Wayne, because maths loves the rules.
It does love rules.
So, I like modulus. Modulus is good. So that gets rid of it, so that gets rid of the minus. So it's modulus x, sorted, but we're not done there, are we, Wayne?
Because what happens if you divide by 0?
Yeah, maths teachers blow up, and it's a nightmare to clean.
Especially in a super lab.
The ceiling's really high, you have to like...
Yeah.
It's not good.
It's horrible.
It's bad.
So we've got to make sure that it's specified x does not equal 0.
Yeah, add
for
that
this to apply.
parameter.
And it gets even worse.
It does. So, this is where our first rule comes in.
Yep, the rest is just remembering things. This is a rule.
This is the first rule of many. So Wayne's memorised it, maybe. So I'm going to check it as he goes.
So, it's a snake.
It is a snake, that's a very important integration.
1
I love
over an
snakes.
x.
Yeah,
with a
that's
b
not a guitar, an x plus b, yeah.
by the x.
Ah.
So if we integrate that, we are going to get, you ready?
Alright, I'm ready.
You're going to get 1 over a
Yes.
ln ax plus b plus c. And I think that's a plus there, is it a minus or is it a times?
No, that's right.
Yes,
As is.
yes. I wasn't convinced of myself. That's a ln there.
Yeah, not a special modulus then. There you are, and that's pretty handy. Now it does work if you haven't got a b.
Yes.
Just leave out the b.
Yeah, because if that's 0, it doesn't matter, it's just 0 there, it doesn't matter. It's the same.
That's fine. I have an example where that applies.
Okay,
You ready?
I'm ready. What colour shall I do it in?
I think whatever you like, Wayne. Maybe blue, green. Oh
Maybe.
no, I think blue. I think
Blue.
green.
Blue's really good.
Green is notoriously hard to read on whiteboards, I think.
Ah, yes, I'll show them the light.
So here we are. We have find the integral. So snake of open bracket 3 minus 2 over x dx. There's a close bracket there. It does say it's between 2 points, but you know how to do that, so we're just going to forget that.
Okay. Firstly, we're going to integrate each of these things, but I can't integrate it like that, so I'm gonna write it again here.
Okay.
It's going to be 3 minus 2 lots of 1 over x. You can think of it as being
That works fine.
the x, because then I can actually go ahead and integrate.
So first step, integrating 3. There is an invisible x to the power of 0 there, so you increase the power by 1, so it becomes 3x.
Yep. Now here we've got 1 over x, which we're saying is ln mod x. This is a simple version, there's none of the ax plus b. So just simply that, ln mod x. So we've got a 2 in front of that.
Yeah.
So it's going to be minus 2
2 ln x.
ln mod x.
Yeah, mod is important.
Plus c, which we won't need for the rest of the question, we can just ignore it because we're putting points in. As Triv said, you know how to put points in, the rest of it's no different to Core 2 or Core 1. Check out those videos if you don't know how to do that.
Absolutely, and this rule wasn't actually that bad, Wayne.
No, but it's going to get worse.
Okay,
I think,
so I think
a T.
I think 6.
6 at least.
Alright.
See you in a minute.